Good afternoon, grade 11s. Carrying on with the lesson on the eye. Okay, so we are going to first of all talk a little bit about light, which I'm sure that you learned about in physical science in grade 8 and 9, if not before then. You don't have to learn this, but you have to understand this concept. So when a light ray or a sound wave passes obliquely from one medium into another, which has a different index of refraction, the light ray gets bent. That's all you have to know. So if a light ray passes from one medium, for example, air, through into water, then that light ray is bent. And you know that if you look on the left here, no, that's the right. If you look on the right here, it will result in something like this. So the light rays that are passing above the water are not being refracted, but the light rays that are passing from the air through the water to the straw are being refracted. And that's why it gives this particular kind of image. You don't have to know that. All you have to know is if light hits a different medium at an oblique angle, it is refracted and it is bent as a result of that. So, in terms of the functioning of the eye functions like a very simple camera. So, light rays fall on an object. Let's say, for example, I have in front of me an apple. There are light rays that fall on that apple. Two things can happen to those light rays. They can be absorbed by the apple, and some of them are. Certain wavelengths of light are absorbed by that apple. Certain wavelengths of light are not absorbed by the apple, and they are reflected back into the air. Those light rays, which are reflected by the object, enter the eye and pass through the pupil. So if I am looking at that apple in front of me, the light rays that are reflected by the apple enter my eye. They pass through the pupil. Because the cornea is bent, those light rays are refracted by the cornea. They are also refracted by the lens, which is also, remember, biconvex. And the vitreous humor is jelly-like, so that also refracts the light rays. And what happens is an inverted image. This image that falls on the retina here is actually an upside-down image. But if the eyes function correctly, it'll be a focused image. So it's there, it's upside down, it's focused, and it falls on the retina. So the rods and the cones of the retina react to the stimulus and they send impulse through the optic nerve to the brain. Okay. So going through that again. Light rays fall on this object. According to the material from which this object is made and the colors which it is painted, it will absorb certain of those light rays, but it reflects the rest of them back. And those light rays, and there will be light rays from all parts of this object, pass through the air and they will enter the eye and they will pass through the pupil and they will hit the retina. Along the way, they are refracted by the cornea, the lens, and the vitreous humor. And because of that, the image which falls on the retina is inverted. It's actually also flipped from left to right. And I wish we were back at school, because there's a way of me setting up a set of apparatus which actually shows you that it is definitely inverted. Okay, but you have to trust me on this. It's inverted. Okay, and it's flipped from left to right. Okay, so light from a point, from any one of these points, travels in all directions. These light rays enter the eye, they're refracted by the cornea, they're refracted by the lens, and to a certain extent they're refracted by the vitreous humor. And what that does is it forms an inverted image, and flipped left to right image on the retina. Because the retina contains rods and cones, those rods and cones will then send an impulse to the little neurons with which they synapse, and those neurons will then send an impulse to transmit an impulse to the optic nerve, to the occipital lobe of the brain, where it is interpreted. Okay, so the image that falls on the retina is inverted, and it is flipped from left to right. Once the impulses from the retina reach the brain, it's the brain that inverts the retina, the image, so that it is the correct side up. Now, it's quite interesting because lots of experiments have been done on this. And researchers have done experiments where they put a lens in front of the eye that actually flips from left to right and inverts light rays before they enter the eye. So the light rays, which then reach the retina, are the correct way up, and they're no longer back to front because they were flipped here, and by the time they reach the retina, they're the correct way up, and they're not flipped back to front, left to right, I mean. So the impulse going to the brain is of an image the correct way around. And for the first little while, the brain does what it always does. It takes that perfect image and it flips it in both directions, upside down, back to front, and whatever. And so for a while, that individual will actually be perceiving everything upside down, even although the actual object that they were looking at is not upside down. And then over quite a short period of time, after a few hours or so, the brain actually adjusts and it stops doing its normal inversion and flipping thing. And so at that point, the individual will then obviously see everything upside down and back to front. And then if the lens in front of the eye is removed, then the whole process starts again, because then the brain has still got to adapt, etc., etc. But the brain and the perception of images is absolutely incredible what it is able to do. And when we get onto the part where we talk about problems with eyes, people who are short-sighted, people who are long-sighted, I will explain to you a whole lot of stuff about the brain and how it actually works in terms of perceiving an image. Okay, so the important thing here, light rays hit an object. Some of those light rays are absorbed by the object, and some of the light rays are reflected by the object. Those light rays that are reflected, if they enter the eye, are refracted or bent, don't use the word bent, by the cornea, the lens, and the vitreous humor. So the image which hits the retina at the back of the eye is inverted, in other words, upside down, and it is flipped left to right. Okay, that's terribly important. And then that will then start an an impulse in the photoreceptors, and the photoreceptors will transmit that impulse to synapsing neurons, which are good old sensory unipolar neurons, which then will transmit an impulse through the optic nerve to the occipital lobe of the brain, and the occipital lobe of the brain interprets that image. And the occipital lobe, that center in the occipital lobe, will automatically flip the image so it no longer appears to be inverted, and flip it from left to right so that it no longer appears to be mirror image or back to front. Okay. All right. And that's vision, and that is important.